Okay, so let's talk about trim a binary search tree. So you're given the root of a binary search tree and the lowest and highest boundary as low and high. Trim the tree so that all its element lies in between low and high. So trimming the tree should not change the relative structure of the element that will remain in the tree. So the idea is if you see the node value inside the tree which is not in between low and high, you just eliminate it. But when you eliminate it, you don't want you don't want to reconstruct the tree. So the idea is you reconnect the node left and node right to something else. That would be the idea. So let's talk about how I actually use it. So I use a recursion. So you will see what happened. So if root equal to null, there's nothing you can return, just return null. And if root.val is greater than high, you do something. If root.val less than low, you do something else. So if the root value is greater than high, which means you don't want this you don't want this subtree, right? So you need to go on the left side, because by binary search tree, the high value on the right, the low value on the left, right? So you will just return trim bst root.left and low and high, and exactly the same idea. You don't want a low value, right? And you can return the right subtree, root.right, low, high. That would be the base case, and they just talk about how you actually need to reconnect the node.left and node.right. So root.left will be equal to trim bst root.left and low and high. It will be exactly the same thing. And as you expect, you can also do root.right for the root.right, and at the end just return root. So that would be the solution. And since you already eliminated, so you don't have to take care of the cases in root.left and root.right. This will already help you to handle which one you should remove. So let's just run the code and see if there's an error. Okay, it's pretty good, right? So let's talk about time and space. So for the time, you need to traverse every single element, every single node in the tree. That will be all of them. And for the space, since I'm not quite understanding, but the space complexity will be all of them, because even though you do not create a tree node for each element, but in a stack you need to store the space for the return value that will return the a tree node for every single node, and that is why for the worst case that is all of them for the space complexity. But that would be the solution on the answer. And I'm not quite understanding. If you do, please leave a comment, and I will look at it later. All right, peace out.